So in this video, we're going to be looking at factoring trinomials, and I'll explain what that is in just a moment. But I've got some examples here first, and actually the factoring is going to come at the very end. But if we can't do this first stuff, then we can't factor. So this is going to kind of lead into what we're going to talk about. So what we're going to do, excuse me, is we're going to multiply these two binomials together. And there's often two very common ways that you might learn this. And so one method often is called the box method, or sometimes people call it the area model. It's very, very similar to Punnett squares in biology, if you've taken that. So what we do is we just write one polynomial on one side and one on the other side. And then when they call it the area model, it's because you're just basically finding the area of a bunch of rectangles. And so x times x is x squared. X times, and so that goes in this box. In the box right below that, we do 4 times x. We're finding the area of this rectangle. So this side is 4, this side is x, so this would be 4x. In this upper right box, we do 3 times x, so that'd be 3x. In the lower right box, we do 3 times 4, which is 12. And so this ends up being, what we're going to do is we're going to combine like terms. And so we have a 3x and a 4x. And so this ends up being x squared plus 7x plus 12. Okay, and I'll explain why this is important in just a moment, but being able to do this skill is going to help us learn how to factor. All right, another method you might see instead of this box method or area model is what it's traditionally called, is distributing. Sometimes it's called FOIL, and that stands for first, outer, inner, should have left myself some room here, and last. First, outer, inner, last. And what that means is you take the first, x times x, that's x squared. The outer, which is x times 7, so 7x. Inner would be 1 times x, so 1x. And last would be the last two numbers, so plus 7. And then you combine like terms here. It's basically just another way to organize it. So this ends up being x squared plus 8x plus 7. All right. So these are our two answers for the first two. And so I'm going to actually do the foiling method or the distributing. Basically, all you're doing, if you forget the FOIL acronym, just remember you're going to distribute. If we look at example 3 here, you're going to take this x and you're going to distribute it to both things in the other parentheses. So x times x is x squared, and x times 5 is 5x. And then I'm going to take the 7, and I'm also going to distribute that to both things. So 7 times x and 7 times 5, so plus 7x plus 35. So our final result here, if we combine like terms, is x squared plus 12x plus 35. All right, so for our fourth example, we're going to do the same thing. I'll do this double distributing method. X times x, x times 3, so that's going to be x squared plus 3x, and then minus 5x, and then minus 15. So this ends up being x squared minus 2x, because we combine like terms, minus 15. All right, so what I want you to notice here, this is the really important part of what we're talking about here, is I want you to look at these two numbers, 3 and 4, and in the second example, 1 and 7, and in the third example, 7 and 5. And in the fourth example, -5 and +3. And what do you notice about those two numbers in relation to the middle number and the last number. So in the first example, we got plus 3 plus 4. In the middle, it's plus 7, and the last number is plus 12. What about over here? If we have, in example 2, we got plus 1 and plus 7. The middle term is 8x, and the last term is plus 7. Or over here in example 3, we've got plus 7 plus 5. Middle term is 12x. Last term is plus 35. Hopefully you're seeing this pattern here. And in the last one, we have minus 5 and plus 3, so we get minus 2x. And minus 5 and plus 3, we get minus 15. So what I hope you notice is that the middle term, if we look at example 1, 7x, 3 plus 4 is 7. So 3 plus 4 is 7. That's going to be the middle term. And 3 times 4 is 12. So if you add those two numbers together, you get the middle term. If you multiply them, you get the last term, which we call the constant term, the one without any x. So the x term, add them together, constant term, multiply them together. So let's try doing that with 4 more examples, but rather than doing that box method or the rainbow method, some people call it, foiling, distributing, whatever, let's just try to use that pattern we saw. So we know it's going to be x squared. And then if we have 5x and 8x, that's 13x. And remember, we just do 5 plus 8 is 13 is kind of that shortcut. And then 5 times 8 is 40. Okay, on this next one, it's going to be x squared. And if we have 9 minus 2, that's going to be plus 7x. And then 9 times negative 2 is negative 18. How about over here? We've got in example 7, we've got x squared. And then we've got minus 10x and plus 10x. So that just cancels out, so there's no x term. You could write a plus 0x, or you could just leave it out of there. And then we've got negative 10 times positive 10, so that's going to be minus 100. Either of these are acceptable. You'll traditionally see it written like the second one. And then the last example, it's going to be x squared. We've got minus 4 minus 3, so that's going to be minus 7x. And then negative 4 times negative 3 is going to be plus 12. All right, so we did a bunch of examples, and we still haven't talked about factoring until now. What factoring is we're undoing all that stuff we just talked about. So you're figuring out what two things were in the parentheses to get that answer. So you're working the other way. This is called factoring. Factoring just is saying what two things multiply up to give me this. If I asked you, we'll do a really quick side example. If I asked you for the factors of 12, you might say 1 and 12. 2 and 6, 3 and 4. Those are the things that multiply up to 12. Well, what we're doing here is we're figuring out what two binomials multiply up to give me this trinomial. So I know it's going to be x and x for that first term. And then I need to look at what things multiply up to 16. So 1 and 16, 2 and 8, 4 and 4. And remember, we talked about on that last slide, it's got to add up to 10x. So that's going to be 2 and 8. So it's going to be x plus 2, x plus 8. And if you're ever unsure of yourself, or if you're ever unsure of yourself, just multiply it out. We're going to have x squared plus 2x plus 8x. And then plus 16. And look at that. That is exactly what we started with. Because if you combine like terms, you get that 10x in the middle. All right, let's look at the one right next to it. I know I'm going to have x times x to give me x squared. And I need to look at what are the factors of 21. 1 and 21, 3 and 7. I think that's it. And somehow I need to get negative 4x. Remember, actually, this is negative 21. So that tells me that I need to have one of these two factors be negative. So that's going to be 3 and 7. Positive 3, negative 7. When I add those together, I get the middle term, which is negative 4. And when I multiply them, I get the last term, which is negative 21. It's going to be x plus 3, x minus 7. All right, let's run through the last two examples, and then we'll call it good on factoring trinomials. So I know we're going to have x times x, and I want to list out the factors of 16. Thankfully, I've already done that, so I don't have to think too much. 1 and 16, 2 and 8, 4 and 4. And I want my factors to add up to 8. So we're going to use 4 and 4. It's going to be x plus 4, x plus 4. All right, and then the last example, we want factors of 5. Well, that's pretty easy, right? It's just 1 and 5. 5 is a prime number. So it's got to be 1 and 5. But I need to get negative 6. So that means I've got to have both of these be negative. So x minus 1, x minus 5. So remember, it's got to add to this and multiply to that. Now, as we go along in this factoring, game, it's going to get a little bit more complicated. But all of these examples are when that number out in front of x squared is 1. Once that number out in front of x squared is no longer 1, then it's when it gets a lot more complicated. But for all of these examples, when the number in front of x squared is 1, all you got to do is find numbers that add to the middle term and multiply to the last term.